What's up? I'm Vin, and today I want to show how to solve rational equations. So we're starting with this equation here, and I'm going to write this out. We have x over x plus 5, and I'm going to leave a little space, plus 9 over x minus 5. And I'm going to leave another little space. We have equals 50 over x squared minus 25. And the thought process for these questions is that I like to think about the most complicated denominator there is x squared minus 25. And x squared minus 25 breaks down to x plus 5 times x minus 5. So I already see that these two fractions have one of the factors of the last one. So the idea that we want to go with here is that we want to complete these denominators. So notice x plus 5 needs an x minus 5 to match the last fraction. So we have to multiply the first fraction by x minus 5 over x minus 5. And then notice the second fraction here with the denominator of x minus 5 is missing the x plus 5 factor. So we have to multiply this one by x plus 5 over x plus 5. And then from here we simplify this. X times x minus 5 is going to give us x squared minus 5x over x plus 5 times x minus 5 is x squared minus 25. And then the next fraction, if we distribute the 9, is going to give us 9x plus 45 on top when we multiply. And then x minus 5 times x plus 5 is x squared minus 25. And this is once again equal to 50 over x squared minus 25. Now with these questions, before you get too far into the algebra, one thing I really like to do is say which values of x are not allowed. And notice that if x is equal to 5 or negative 5, if x is equal to 5, the second and third fraction are going to have a 0 denominator, and dividing by 0 is undefined. And if x equals negative 5, the first fraction is going to have a 0 denominator. So these two solutions for x are not allowed. Now we go forward with this here. The moment you get all your denominators to match, you can cross off all the denominators involved, but as long as they all match. And now we just write the leftovers here. So the leftovers, we have x squared minus 5x, and then the second fraction we're left with plus 9x plus 45, and this is equal to 50. So now we could subtract 50 on both sides. And notice here we're going to have 0 on the right, and on the left we could also combine negative 5x plus 9x. So we're going to have x squared negative 5x plus 9x is plus 4x. And then 45 minus 50 is going to give us minus 5. So now we just have to factor this. This is going to factor to x plus 5 times x minus 1 equals 0. Remember how to check. 5 plus negative 1 is 4, and 5 times negative 1 is negative 5. And now the roots that we get out of this are going to give us x equals negative 5 and x equals 1. Now if you're not careful here, people are just going to say that they have two answers. But remember what we said before. X equals negative 5, we have to reject, because that would make the first fraction have a 0 denominator. Now before we move on to the next example here, I highly recommend that we check this. So what we have to do to check, we just plug in the only value of x that works. So x equals 1 is going to give us 1 over 1 plus 5, plus we have 9 over 1 minus 5. And this has to be equal to 50 over 1 squared minus 25. So then to check this, we just have to do the math here, simplify this. This is going to give us 1 over 6. And this is going to give us 9 over negative 4. And 9 over negative 4 is the same thing as saying minus 9 over 4. And this is going to equal 50 over negative 24. So I could just say negative 50 over 24 like this. Now, a few things that we could do here. We could reduce the right side. And notice this is going to reduce on this side to negative 25 over 12. And then for this side here, if I want to make both of them have a denominator of 12, I'm just going to double this one, top and bottom. I'm going to have 2 over 12 minus, and if we multiply the top and bottom here by 3, we have minus 27 over 12. And you can see here, 2 minus 27 is going to give us the negative 25 over 12. So our solution checks out. Now for these questions, sometimes there's a nice little shortcut. We could do exactly what I did before, or what we could do is just subtract 1 over r minus 2 on both sides right away. And I'm allowed to do this because these two fractions have the same denominator. So when we simplify, we have 1 over r squared minus 7r plus 10 equals, and I'm just subtracting the numerators. 6 minus 1 is going to give us 5 over r minus 2. So now the thought process here, when I look at this, I automatically think that r squared minus 7r plus 10 is equal to r minus 2 times r minus 5. So the missing factor for that second fraction is going to be r minus 5. And remember what we said before. Before we get too far into these examples, we should say which values of r are not allowed. And for that quadratic r squared minus 7r plus 10, if r is equal to 2 or 5, that denominator is going to be equal to 0. And notice if r equals 2, the first and last fractions have a 0 denominator. So our solution cannot be r equals 2 or 5. So remember, once we get the denominators to match, we'll go ahead and write this in the next line. We have 1 over r squared minus 7r plus 10 equals, and then if we distribute, we have 5r minus 25 over r minus 2 times r minus 5 is going to give us the same thing. We have r squared minus 7r plus 10. At this point, we could just cross off both denominators, and we write what's left in the numerator. So we have this. And now to solve for r, this is just simple algebra. Just add 25 to both sides. And you have 26 is equal to 5r. And then divide both sides by 5. And from here, you could just say r is equal to 26 over 5. Or you could say that this is equal to 5.2. So either one of these is okay. But this is our solution to the second example.
So let's check our answer with the calculator. We're going to write the equation in the y1. The only catch here is that we're going to take the right side of the equation. And we're going to move it all over to the left. So we have the left side of our equation here, and notice we replaced the r with x. But now we're going to move the 6 over r minus 2. We're going to subtract it to the left. That way we can look for when this equation is equal to 0. And we're going to switch it to standard mode. We're going to trace the 0, and we have to go over here to that third part of the graph. Now, it might be a little bit difficult to see what's going on, so we could do the zoom box, and we could just, kind of like we're cropping a photo, zoom in. And now it's very clear where the intersection point is. And when we trace that root, we're going to go to the left and the right. Our answer checks out at 5.2.
Now, the moment any subtraction is introduced to these questions, there's a very dangerous trap. Remember, our thought process is the same. That what I'm thinking of on the side is I'm thinking of how does this fraction, well, how does the denominator actually factor out? So how can we factor this expression here? And that factors as k plus 3 times k plus 2. So notice the k values that are not allowed, we cannot get k equals negative 3 or k equals negative 2. So then what we have to look at here is notice this last fraction is missing a factor of k plus 2. So what we want to do here is we want to multiply that last fraction by k plus 2 over k plus 2. And if we work this out, notice at this stage, all the denominators we could say will cross off. But the dangerous trap here is you have to be careful. When you're subtracting, make sure you put whatever you're subtracting, that numerator, make sure you write it in parentheses, because one of the most common mistakes I see here is that people write something like 3 minus k minus 6. But just know you're subtracting the entire numerator, so you have to put it in parentheses. And on the right side, we're left with 1 times k plus 2, or just k plus 2. So now we distribute this negative, and we have 3 minus k plus 6 equals k plus 2. And then to solve here, we could just simplify this. We have 3 plus 6 is 9, so we have 9 minus k equals k plus 2. We could subtract 2 on both sides and then add k. And notice this is going to cancel out. 2 minus 2 will cancel, and we have 7 is equal to 2 times k, which tells us that k is equal to 7 over 2, or we could say it's equal to 3.5. So here's our solution to this example here.
So now let's use technology again to check our answers. So we type in the original question, and instead of using k, we're going to use x. So we're typing in the left side of the equation, and then we're going to move the right side of the equation over. The 1 over k plus 3, well, we're calling it 1 over x plus 3. We're going to subtract that over to the left side. So right after this, we have 1 minus, and we're going to have x plus 3. And we're going to graph this again, and because we moved everything to the left, we're looking for the 0. So we're going to turn the first graph off by hitting enter on the equals. And now when we look at our graph, we could zoom in. Like we're cropping a photo, we'll just section off the graph where the graph goes through the x-axis. And we trace the 0, we go before. Notice y is in the positive. We scroll to the right until y is negative. And it tells us x equals 3.5.
Okay, well, this is going to conclude this video on solving rational equations. If this video was helpful, please like and subscribe. It really helps me grow the channel. And if you got any requests, just leave the topics you want me to cover in the comments section below. And thanks for watching.